Here's the last video on writing ionic formulas. We're looking at something called a polyatomic ion. Poly means many. Atomic refers to atoms. This is a group of many atoms bonded together. They look like they could be a little compound, but they're not neutral. They have a charge. That's why we call it an ion. For example, NO3 looks like it could be a little compound. But if you really want to bond nitrogen with 3 oxygen and give everybody a full octet, which is the purpose of bonding, you'll be short by 1 electron. So this little guy is not neutral. He needs 1 more electron, -1. If we gain 1 electron, then nitrogen and oxygen can bond and give everyone a full octet. So this polyatomic ion concept is just that. It's a group of atoms bonded together, but they have a charge, and they just have 1 charge. It acts as 1 single ion. The whole thing has a -1 charge. A lot of their names will end in ATE. So this is called the nitrate ion. Not to be confused with N-3 nitride. If you're looking at the regular element, the singular element on the periodic table with its charge, that should end in IDE. Nitride, oxide, sulfide, phosphide. Now if you're talking about the group, often it'll be the element bonded with oxygen. The ending will change to ATE for a polyatomic ion. For example, you can have SO4 -2. That's sulfate. It's the sulfate ion. If you want to bond sulfur and 4 oxygen, you'll need 2 more electrons. Then everyone gets a full outer shell. Sulfide would be just regular sulfur -2. Sulfide. So now you have to be a little bit careful when you're writing formulas. Watch the ending of the anion. Does it end in ATE? Then it's probably a polyatomic group. The IDE would be the regular element off the periodic table. So how do you know these polyatomics? In class, I will give you a big sheet that has tons of them. I mean, there's like 50 polyatomics. You just look them up. I'll give you a sheet that has the NO3 -1, the formula and the charge, and it'll tell you the name, nitrate, sulfate. So if you're watching this because you were absent in class, let me know so that I can get you this chart that has all the polyatomics. You'll never need to memorize them. You'll want to have this chart handy when you're writing formulas, because these polyatomics are very common. And I will give you the chart for any test or quiz. You do not need to memorize the polyatomics. Let's look at writing some formulas. Okay, so sodium carbonate. Sodium is just regular sodium. Its charge is +1. With the ATE ending, that tells me this is a polyatomic group with carbon. And again, often it's like carbon with oxygen, nitrogen with oxygen, sulfur with oxygen. If I look it up on my chart, I'll find that it has a charge of -2. The symbols, Na for sodium, carbonate is CO3. All right, we still just have 2 charges, and we still need to make them add up to 0. So we're probably thinking, let's take 2 sodium. Then I'll have a +2 -2. You need 2 sodium, then you put the little 2 in your formula. Na2CO3. Done. Well, that's not so bad. These polyatomics act as one ion. They just have more than one atom. Copper 2 nitrate. Copper's charge is +2. ATE. Nitrate, I look it up on my chart. -1. The symbols, Cu for copper, nitrate is NO3. I need to make this neutral, so I'm probably thinking double the nitrate. Then we have a +2 -2. If I have to multiply the charge times 2, that means I need 2 nitrate groups. To show 2 nitrate groups, you must put it in parentheses. And the 2 goes on the outside. If you don't put the parentheses in, it kind of looks like NO32. And we don't mean for there to be 32 oxygen. There's actually 6. We could also write this, it would look kind of funny, but you could say like copper, nitrate, nitrate. The copper is +2, each nitrate is -1. So it is neutral. The entire group, NO3, is -1. But again, to shorten it up, because that could get kind of crazy, we'll just put the NO3 group in parentheses, and the 2 on the outside tells me there are 2 groups of nitrate. Oh. Okay, so now in the first one, sodium carbonate, parentheses optional. We only need 1 group of carbonate. But if you're ever in doubt and you're not sure, do I need the parentheses? You can put them in there and it would never be marked wrong. So if in doubt, just put them in parentheses. But you don't need it if there's only 1 group. Interesting. So for example, skip to that iron 2 phosphate. Iron's charge is +2. Phosphate, I see the ATE, so that tells me to look on my chart. -3. The symbols, iron and phosphate, is PO4. Okay, so we need to make this neutral. And again, I only have 2 charges, so I'm probably looking for like a plus and -6. So how about 3 iron and 2 phosphate? Those become my subscripts in the formula. I need 3 iron and I need 2 phosphate groups. So again, now I must put phosphate in parentheses and the 2 goes on the outside. Otherwise it looks like PO42, and that's not what you mean. There's actually 8 oxygen. This 2 would get distributed. There's 2 atoms of phosphorus and there's 8 atoms of oxygen, not 42. The one in the middle is kind of a goofy one. Ammonium hydroxide. This is one that people get wrong a lot. Ammonium is a positive polyatomic ion. Its charge is +1. Its symbol is NH4. It's the only positive polyatomic on your chart. People get it wrong because there is an element on the periodic table with a symbol of Am. But that's americium. It's way down on the bottom in that F block. Radioactive, unstable. So be careful with ammonium. It's NH4 +1. Hydroxide is also a polyatomic. It doesn't end in ATE like most of them do, but its symbol is OH. So people usually get this one right because it's like a hydroxide, hydrogen and oxygen. And you can look it up on your chart, and and the charge is -1. And so guess what? This is neutral right away. Ammonium hydroxide. It's a very common compound, and we will use it in the lab. It's a base. +1, -1, it's neutral as is. So again, if you wanted to, you could put parentheses, but they would be optional. Both would be optional, because you only need one group of each. People sometimes ask too, can you combine the hydrogen? Could you say NH5O? You could, but not necessary. This kind of shows how the atoms are grouped together. First, you have a nitrogen surrounded by 4 hydrogen. Then you'll have an oxygen with 1 hydrogen. So you can leave them as is. Perfect. So here's writing formulas with the polyatomics. Not super crazy. Let's look at naming them. Naming compounds with polyatomics. Again, a lot of the same rules apply. There's a positive ion and a negative ion. So these names should have 2 parts. If you see something in parentheses, then you know that it's a polyatomic. If you don't see it in parentheses, but look at the first one, NaNO3. After a while, you'll kind of get used to these because the polyatomics are very common. Well, this is obviously sodium. And the second part, this must all be my negative. The sodium is +1, NO3 is -1. That's nitrate. So again, if you see like 2 non-metals at the end, especially if one of them is oxygen, I bet it's a polyatomic. And the more you use them, the more you'll get comfortable with them. Oh yeah, that's nitrate, NO3. There, that's it, sodium nitrate. You do not need a Roman numeral because sodium is only +1. So now let's look at this little guy, lead. And again, if I see the parentheses, I know it's a group. So you look it up on your chart. Sulfate. Now with transition metals, tin, and lead, you must use the Roman numeral. Lead can have different charges, so I have to indicate which form of lead is used in this compound. So to figure that out, we just work backwards. Sulfate, the sulfate group is -2. In this compound, there are 2 groups of sulfate. So on the back end, I have a total charge of -4. I only have 1 atom of lead, so the lead must be +4 to make the compound neutral. Lead 4 sulfate. SO4, the polyatomic sulfate. Similar with the next one. Iron is a transition metal, so I know I'll need the Roman numeral. And then OH, it's in parentheses, so I know to look on my chart. Hydroxide. And I promise, we use these polyatomics all the time. So you have no choice but to kind of get used to them. And again, if you're in doubt, look them up. You'll always have the chart. You never have to memorize them. But some of them you really will start to recognize quickly. We use hydroxide all the time. Nitrates, really common. So now I just have to figure out the Roman numeral. I look up the charge for hydroxide, -1. In this compound there are 3, which gives me a total charge of -3 on the back. And again, there's only 1 iron, So that one iron must be plus 3. Iron 3 hydroxide. Roman numeral 3. Done. So a lot of the same rules apply. We still use the Roman numerals for transition metals, tin and lead. And to figure out the Roman numeral, we just balance the total negative charge with the total positive charge. And the last one, that NH4 group, again, that's the one that people forget a lot. It's ammonium. You do not need a Roman numeral. It's always plus 1. And then here, regular sulfur is sulfide. So I like these examples. This is the IDE versus the ATE. The group with oxygen is ATE. The regular element is IDE. And again, this compound makes sense because sulfur's charge is always -2. So to make this neutral, I'll need 2 ammonia. But since it's a group and you need more than one, you would have to put the ammonium, NH4, in parentheses. Ammonium sulfide. Alright, so to be honest with you, the best way to learn these things is just by doing them. So on the last sheet here, there is a boatload of practice. Practice writing the formula and practice writing the name. It's really the best way to get good at them. Just do a bunch of them and check the answers and make sure you're getting them right. So at this point, I would do that. I would pause the video, try some of these where you write the formula, and then try some where you write the name. Then bring back the answer key and check to make sure you're getting them right. If you are, great. You're in a good place. This is clicking, which is good because you must master the art of writing ionic formulas. It's not going away. We're going to use this all year long. If you find that you're not getting them right, then you need to come in immediately for some intervention. And it might only take us 5-10 minutes. Show me the ones that you're getting wrong so I understand what mistakes you're making. But this is a skill that you'll want to master. So again, I'll show you the answer key to the last page. If you want to pause at any time, go ahead so that you can copy those answers and make sure you are getting them right.